Welcome, everybody. It is noon Eastern Time. We're going to get started with another installment of the Ecopath online seminar series. We have a panel here today to answer some of your questions, even if you have questions for other people than the speakers, including me, Sheila Haymans, Billy Christensen, Christy Lewis, and Lee McGaughy. Next slide, please. So we're doing this every 2 months, every last Tuesday of the month at noon Eastern Time in the U.S. My name is Kinda Matserd, actually, if I haven't said that yet. Today we have our installment, obviously. The next one will be in November, at November 24th, then January 26th, and then March 30th. Next slide. And I'll be your host today because our speaker is actually a PhD graduate of my lab, Dr. Tunde Adebola. He has a Bachelor of Science in Fisheries from Lagos State University in Nigeria and a Master's of Science in Marine, Estuarine, and Environmental Science from the University of Maryland, Eastern Shore in the U.S. After that, he joined my lab. He obtained his doctoral degree in Environmental Science and Public Policy at George Mason University, where he worked on his dissertation entitled Investigating Anthropogenic Impacts in Nigerian Coastal Waters Using Ecosystem Fisheries Modeling Approaches. He will actually be talking about his dissertation research to you today. For his research, he developed an Ecopath Ecosim model, did a lot of work in Ecospace, which you will hear about today, and he used that to examine the ecosystem consequences of spatial redistribution of fishing effort in nearshore waters of the Nigerian coastal system. He has published several papers, so those of you interested, I can post links to those papers to the Facebook page and the website after his presentation. And when he left my lab, he continued on as a postdoc at Hampton University. He first did his research at the Minority Men's Health Institute, also teaching biology classes, and he has recently been offered a research faculty position at Hampton University. So with that, next slide. Tunde will get ready to present his talk on spatial simulation of redistribution of fishing efforts in a coastal mixed fisheries using Ecospace. So with that, I'll leave you with Tunde.
Can you all hear me? I cannot see you, but if you could hear.
Yes, we can hear you. We can hear you.
Thank you. Good afternoon, good morning, and good evening. Thank you so much for joining this webinar. Thanks, Dr. Demotad, for that introduction. I'm happy to share with you what I learned from my 3.5 years of learning in Dr. Demotad's lab at George Mason University. This afternoon, I will be speaking on spatial simulation of redistribution of fishing effort using Ecospace. And so my research focused on Nigerian coastal waters. The shelf area is about 40,000 square kilometers, and about 75% of that seascape is fishable. What's important is that 80% of the fishes in these coastal waters spend at least a part of their life cycle in the Niger Delta. The Niger Delta is the third largest contiguous mangrove ecosystem in the world. So it's a very important ecosystem. And I thought that modeling these coastal waters will be useful for people who want to do research in this arena. And so the rationale for doing this research is that the sea fisheries fishing regulation in Nigeria for 1992, the decree, the item number 1 of this decree states that talks about restriction of fishing in certain areas. It specifically says that no motor fishing boat except canoes shall fish within the first 5 nautical miles of the waters of the Nigerian continental shelf. And so this is the law. And why is this important? It's important because we have two relatively important sectors within the fisheries in Nigerian coastal waters. We have an open access artisanal fisheries that more than a million fisher folks are involved in because this supports them, their livelihoods. It's about people. Fisheries is about people. So a very huge population of folks are engaged in fishing in this sector. There's also an industrial fishery. About 150 to 250 fish trawlers are licensed every year, particularly beginning from 1985 when shrimp fisheries became very important in Nigerian coastal waters because fisher folks were interested in exporting shrimps, particularly to Europe, Japan, and some of them actually also import into the United States. So for the sake of foreign exchange, a lot of people began to fish for shrimps, and this led to overcapitalizing the shrimp fishery. This slide just shows the important commercial fish stocks. These different fisheries make up more than 40% of landings. We have pack-like fishes like threadfins. We also have herring-like fishes like shads. The Penaeus notialis fishery became very important beginning in the 1980s until it was overcapitalized at the turn of the century. And that's one of the reasons why I decided to do my research in this area. So basically, the law states that the two fishing subsectors should be spatially separated in their operation areas. But around the turn of the century, depletion of Penaeus notialis, that is the pink shrimp, changed the spatial arrangement, and some of the trawler boats began to fish in nearshore waters that are restricted from benthic trawling. It means that they were fishing in a special seascape that was specifically designated for artisanal fisheries. And so I just made a schematic to show essentially what happened. This is a concept that I thought of. We see a spatially separated fisheries where the first 18 meters water depth is specifically designated for small canoes and artisanal fisher folks. And deeper waters more than 18 meters deep, were the area of the continental shelf where industrial benthic trawlers and also pelagic trawlers could fish in. Like I mentioned earlier, at the turn of the century, there was this overlap in the fishing area where these large 20 to almost 40-meter boats began to fish in nearshore waters because of depletion of Penaeus notialis, that is the pink shrimp, in deeper waters. And so they began to target other shrimp species like brown shrimp and nearshore species like estuarine shrimps. Because of this spatial overlap, some of the people in the industry and also managers, stakeholders began to feel that this may have negative environmental consequences. But there was no empirical study to back up these claims. And so even though I did my research about 10 years later, I wanted to understand what the ecosystem impact of the spatial redistribution of fishing effort would be. I wanted to see, conceptualize these and have at least some numerical basis for saying that, yes, it's true or no, it's not. So the goals for my research was to develop a coast-wide ecosystem fisheries model, review the status of fisheries in Nigerian coastal waters, and understand impacts of fishing using a spatial framework within an ecosystem model. I used Ecospace to model and examine impact of trawl fishing in the 5 nautical mile no trawl zone designated in Nigerian coastal waters. And this research is important not just for Nigerian coastal waters, but a lot of developing countries have similar, fishing arrangements like Nigeria. So lessons learned from this research can be applied beyond the shores of Nigeria. And when researchers in those other systems carry out their research, we could also learn and adapt lessons from their own system to Nigerian coastal waters. So my approach was to use Ecospace, like I mentioned earlier, specifically use the new approach in Ecospace, which is the habitat capacity modeling. In this approach, a portion of each spatial grid suitable for a given functional group can be restricted, and habitat and environmental factors affect the area each group can utilize for foraging. Habitat preferences and environmental tolerance ranges are therefore converted into a kind of habitat capacity map that will be interpreted based on simulations from Ecospace. It was this approach actually one of the first papers published to describe this approach was by Christensen et al. 2014. And essentially, they are using environmental preference functions for maybe several environmental parameters. It could be temperature, chlorophyll A concentrations, and so on and so forth. And so these will be input as data into Ecospace, and cell habitat capacity values can be calculated based on that information. And so I wanted to address the question, what are ecosystem impacts of fishing in the entire coastal system? What are the implications of redistributing fishing effort from deeper waters, that is waters greater than 18 meters deep, into shallower areas of the continental shelf? And so I followed the logical sequence. I first developed an Ecopath model, and then later on went into the time dynamics simulation and spatial dynamic simulations in Ecosim and Ecospace. And so this is the equation 1 is the master equation in Ecopath that tries to establish mass balance based on the biomasses of commercial species superimposed with the information about the biomasses of their prey and also their predators. So basically, Ecopath tries to establish mass balance based on all of that. And for my Ecopath model, these are the parameters. I simulated, I built a model to account for 22 different groups in Nigerian coastal waters using information about biomass estimates, their consumption, and also mortality information. My data came from various sources, but the main sources of my data were the Sea Around Us website, FishBase, Sea Life Base. Some information I got from the literature, especially fisheries and diet data. This is the Ecopath with Ecosim flow diagram, which is the snapshot of the ecosystem in 1985. So I was simulating what the ecosystem looked like potentially in 1985. And then once I had the parameterized model, I progressed. I promoted that into Ecosim, where I added information about environment and fishing, and also predator-prey interactions based on foraging arena theory, where dynamics of vulnerable and invulnerable prey kind of is important in achieving dynamics within the system. I also tried to minimize errors using the sum of squares error, as you can see, and I came up with two best models, two best simulations. One was a model that had temperature information added to it, and one would just work with the fishing information. And I had better, a better output from the model that had environmental variables as a driving force, as a forcing function. So these are my Ecosim predicted fit to data. As you can see, I had some of the modeled groups fit well to the data, while others did not fit so well. Particularly if you look at medium demersals, I had very good fits. Same thing for large bento pelagics, crocus, pink shrimp, shad, and yeah. But other groups were not so. They didn't fit so well, particularly small demersals and reef fishes, and so even though this is not a perfect scenario, I worked with the best model that I had and promoted this into Ecospace, where I used habitat capacity model, where foraging is driven by ecological and oceanographic factors. Here I used bathymetry. And distribution of model groups is based on habitat maps and environmental preference for each of these groups. My goal was to try to mimic the true distribution for each group based on habitat and environmental information. So for habitat, basically, I assume that fish distribution maps reflect habitat capacity maps. And what I did was to just download the distribution maps for the different groups from FishBase. Aquamaps has some distribution maps for various species that I modeled within my system. So I just put those maps into a GIS system and traced that, converted the vector files into raster, and then converted the rasters into ASCII files. And that was what I put into Ecospace. And then I also used bathymetric information as a layer to ensure that fish distribution stayed reasonable over time. My response curves were mainly sigmodal, as you can see for response curves in figure 6 for deepwater shrimp species, the pink shrimp, and some other shallower shrimp species like the estuarine shrimp I mentioned earlier, and brown shrimps. So for Ecospace fisheries, fishing regulation was achieved using the Ecospace fisheries tool. In that fisheries tool, we have MPA and MPA enforcement and habitat fisheries. And basically what I did was I closed the first 5 nautical miles to fishing for the first 15 years and open it thereafter for my model simulations. And as you can see, my model area covers this. If you look at the Nigerian map, this is the map of West Africa as an inset, the map of West Africa and Central Africa with Nigeria. The area in the box is the area I modeled. So if you see the arched section of that map, that is the 5 nautical mile zone that is close to fishing. And basically I modeled almost a 460-meter depth for the coastal waters. So for my model simulation for biomass, catch rates, and fishing effort was undertaken over a grid map of about 16,600 grids with a spatial resolution of 0.031. 2 scenarios were simulated by maintaining a 5 nautical mile non-trawl area beginning from the shoreline in one scenario, and the other scenario allowed benthic trawlers fish everywhere. A gravity model spreads fishing effort in Ecospace and limits fleets to habitats or to fishing MPAs when such fleets are assigned to fish there. And so these are my Ecospace results for artisanal fisheries. That's just the distribution of fishing effort. Distribution of fishing effort for benthic trawlers, and distribution of fishing effort for pelagic trawlers. Catch rates, for catch rates, one thing I noticed was that fisher folks were catching more in the trawl fisheries in 1985. For benthic trawlers, they were catching way more in 1985 than they were in 2004, which was the last year of simulation. And regardless of the fishing policy, I didn't really see any big changes in the fish biomass that was caught by fishermen. For pelagic trawlers, fisher folks were catching more at the end of the simulation that they did at the beginning of the simulation. Perhaps maybe this is due to shifting regimes in biomass of pelagic species like shards. Ethmalosa fimbrata has been shown to track temperature data way back, going all the way to the 1970s. So the pelagic fisheries kind of swing with that. And then for artisanal fisheries, we see that the fishing sector was not doing as well in 2004 as they were in 1985. They were catching maybe 2/3 of what they used to. So it means that that sector was kind of struggling by the turn of the century. Then the question that came to mind was, since if you look at figure 10, there seems to be no difference in biomass caught by fishermen. You know, when I closed the MPM, when it was opened, you would think that if fishermen are not catching fish in the closed area, then biomass should increase, and maybe even spill effects should increase fishing to an extent. But that was not the case, and I think it's probably because the large number of artisanal fishermen in the coastal system more than offset for any gains that would have been if that place was closed entirely. So it doesn't seem like closing or opening that spatial seascape to trawl fishing is changing anything in the ecosystem. Then the question was, what is the purpose of the MPA then? Why restrict fisher folks from the trawl industry from fishing there if it doesn't seem like there's any biological gain to that policy? So I had this back and forth discussion with my advisor when I was doing my PhD, and then she pointed to me that, oh no, there is some gain depending on the type of policy you want to pursue. Look at figure 11. You would see that large demersals actually seem to be doing very well when the first 5 nautical miles are close to fishing. So if the fish management institutions are interested in pursuing a policy that protect large demersals, then they may, strictly enforce that 5 nautical mile no trawl zone. Nevertheless, because Nigeria is a developing country, and the spatial extent of the 5 nautical mile no trawl zone is actually almost 1,000 kilometers. So it's actually hard to enforce such a thing. Even though recently, at least in the last maybe decade, the Nigerian Navy has been heavily patrolling the Gulf of Guinea adjacent to Nigerian coastal waters because of increase in piracy in the Gulf of Guinea. But still, it's probably going to be hard for fish management to enforce that type of restriction. And so, why is this important? About 20 years ago, when I was an undergraduate student, my professor, Dr. Wodende, was telling our class, our aquaculture class, that fisher folks were going deeper into the sea to maintain, a reasonable catch to support themselves and their families. So he actually emphasized at that time that aquaculture was the future for Nigeria. And, almost 15 years later, when I finished my PhD, I remembered what he said, because I looked at my model, and if you look at figures 7 to 9, you will see that fishing effort is actually happening. The distribution of fishing effort was actually happening in deeper parts of the continental shelf, which suggests that fishermen were going further away from shore, including artisanal fishermen. And so this is important because fishing effort was mostly exacted outside the 5 nautical miles non-trawl area, making it seem like the 5 nautical mile no trawl zone is ineffective. Ecospace results also suggest that there's depletion of fish biomass, and that this is probably why, you know, what my professor said 20 years ago is happening, because there's this depletion of, there's this wider envelope of area that fishermen really need to reach in order for them to maintain reasonable catch. Then also I thought about large demersals. They benefit from limiting fishing outside limiting trawl fishing outside these 5 nautical mile trawl zone. So if the policy that fish managers want to pursue is a policy that help replenish that biomass in the coastal system, they may, you know, really strictly enforce that MPA. Then also catch rates are reduced for artisanal fisheries and industrial benthic trawlers, but catch rates increased for pelagic industrial fisheries. So in conclusion, there's evidence of fishing impacts in Nigerian coastal waters. These impacts will likely increase in severity with time due to a rapidly growing population. It's important to engage stakeholders and provide alternatives to coastal fishing. For example, I suggested aquaculture earlier on. That may be a way to redirect fishing away from the coastal waters to help sustain fisheries over time. Also, it's critical to consider impacts of fisheries in combination with other anthropogenic stressors. So thank you for listening, and these are my references.
Great, thank you very much, Tunde. Could you mute while I'm talking? Thank you. That was great. So if anybody has a question, please check out the Q&A. So if every other moderator of this can help me by publishing the questions, and I will read the questions for Tunde. We have a little bit of a feedback issue, so we'll mute and unmute in between, so bear with us. But I do already have questions coming in, so I'm going to read the first question from Sheila Haymans. How did you include economic information? Because if you have good economic information on cost of fishing, etc., that would give good results. But changes in the cost of fishing might change what fishers are prepared to spend on fishing. And if you want to read it, you can check out the Q&A as well.
Thanks, Dr. Sheila. I think that's a very good question. I did not include economics in the modeling. I would have loved to, but I don't think I had enough economic information at the time I was developing my model to use economics. And so what I did was just to use habitat information and environmental preference information. And I mean, the model is still in development. It can be further improved with economic information. And so that's maybe something to think about in future iterations of my work.
Can I have a
Yes, go ahead, Sheila. Why don't you ask out loud and I'll mute?
Yeah. it seemed silly for me to type it in and then, yeah. So Tunde, I guess if you just put the cost of fishing in the Ecopath part of it, you don't need that much information, but I think that will actually give, and Veli or somebody else who know more about Ecospace might correct me here, but I think if you put the impact, so cost of fishing for the artisanal fishers might be much less than it is for the trawlers or for the demersal trawlers or so, and so that might change how your Ecospace distributes itself. Because the way the fishermen in Ecospace go is, where the fish is, but also how much how much money they get for the fish. So I think that it's quite important that you kind of incorporate some sort of value of fishing, how much the fish is valued and what the cost of the fishing is in your Ecopath model in the very first step, if you want to get a really good handle on that in the future. So that's all I had.
Yeah, I'll do. Thank you.
All right, the next question I see is from David Richards. Can Ecospace add error bars to changes in total biomass results presented in figures 7 to 9?
Thanks, David. I have not explored that to see whether Ecospace can add error bars. There's probably that function in Ecosim where you can see some of the statistics, but I did not explore that when I built this model. I built this model almost 4 or 5 years ago, and so a lot has changed between then and now. And of course, I can take a look at that again and see where I can improve just the data inputs and have some statistical, some valid statistical inputs, so that it would just not be numbers, but then we have some, errors, our range that indicate how good the data is. So thanks. I will look into that if.
Thank you, Tunde. And if I can add to that answer as well, I would say not yet. Ecospace is not going to do that for you, but we're currently working on doing spatial Monte Carlo runs in Ecospace. So that is going to provide that option. So soon, I would say, may be the best answer. Any other questions? Okay, I see actually the next one from Natalia Terpetti. Thank you for a great presentation. Is the water temperature changed? Has the water temperature changed a lot for climate change in this ecosystem?
That's a good question too. The water temperature varied a little bit over time. From what I remember in my Ecosim calibration, the water temperature varied very slightly. It's nothing very much, because Nigeria is in the tropics and it's very close to the equator, so it's warm all year round. Nevertheless, that slight change improved my model and helped me to get some better fit to the model when I included environmental temperature from 1985 to 2004. Does that answer your question? So I don't know if I'm going to be able to speak to climate change, because that was not the goal of my research, but I used temperature data to just act as some environmental forcing information in Ecosim.
Great, thank you, Tunde. One other thing I would like to add is that if you have any questions about Ecospace, Ecopath, Ecosim that are not necessarily directed to the speaker or about the presentation, this would also be the time to ask those questions. Perhaps you're just like the question about error bars. You're just wondering about functionality in Ecopath or Ecosim and Ecospace. There's a couple of people here present with us today like Sheila Haymans, Lee McCaughey, myself, Christy Lewis, Philly Christensen, I think, if he's still on, that could answer or try to answer some of those questions. I see another question coming in. I think mostly thank yous and people really appreciating this presentation is what I see coming in. But I'll wait another brief moment to see if people have potentially questions outside of the presentation as well.
Sheila, here again. Maybe I'll just ask my question. I was typing it in and I thought, well, this makes no sense whatsoever. So Tunde, my other question is, did you use regions in Ecospace? Because I know in Ecospace you can set different regions. You could set the biomass inside and outside of the MPA, for instance. Did you do that at all in Ecospace?
Oh, I did not use regions in Ecospace. What I did was to use, I just, if I remember well what I did, I got the bathymetric information and also the habitat information. And then I used MPAs to regulate the fisheries. That was what I used specifically. I regulated the fisheries. And then more specifically, I also, used the function in Ecospace where I can weight the different fishing subsectors. You'll think that the catchability for trawlers should be way more than that for canoes. So there are functions in Ecospace that allowed me to adjust the data in such a way that I will be able to get more realistic simulation estimates. So those are the things I did. At the time, I don't remember seeing regions, and yeah, I did not use it.
Yeah, so because actually if you had set, as far as I remember in Ecospace, you can set regions to be MPA or non-MPA. So you could actually look at the biomass inside and outside your MPAs. Okay. And that actually might give you quite interesting results, so that you would have higher biomasses inside the MPA for the things that are not fished. Okay. And then possibly lower biomasses outside, because your fishermen would then be fishing harder outside the MPAs. Mm-hmm. So that might have given you some really interesting results. And as far as I remember, and probably Natalia is the best person to answer this question, I think you could just, there was a thing that you could just set your regions inside and outside the MPAs, or you could actually, have regions of different parts of the coast. I mean, the regions function is actually really quite easy to use, from what I remember. And then it would give you a really good handle on the biomass inside and outside, the catch inside and outside. So that might be something to think about for future work.
Thank you.
All right, thank you. I have another question from David Richards. How was the detritus modeled, and can it be used as a food source for benthic fishes or shrimp?
So, David, yes, feedback. Can you hear me well? Okay, good. Okay, good. So, that's one of the aspects of the modeling that I had to leave for Ecopath to help me with, because I did not have the biomass for detritus. And so what I did was, I think I had to adjust values for ecotrophic efficiency to be able to get some reasonable balance for my model. So detritus definitely is useful to the system, but I did not have any empirical data to back up that. So what I did was to just adjust my ecotrophic efficiency until I got mass balance.
Thank you, Tunde. And if I can add to that, so this was mostly about like how to set the biomass of the detritus, which we did not have a lot of data for, but it was definitely included as a food source. So in the diet matrix, you can select which of the groups feed on the detritus group. So The detritus is in the model, and it was basically in there with superfluous biomass, enough biomass, and those groups that would feed on the detritus that was included in the diet matrix. All right, other than that, I see some more compliments from Howard Townsend, for example. Nice work. So that's a great way to use the Q&A function as well. I don't see any new questions. We are a little bit early, but I'll mute my phone in a minute and let Lee take over to see if you want to perhaps end our session early or wait a little longer for questions.
Sorry, there's 2 more questions coming in.
Great. I see them. I have a question from Burak. Thank you for the great presentation. I would like to ask a question about the data that we are struggling with sometimes. So fishes move in and out from the location you model. Is it okay to omit all those interactions? I wonder, because we work on inland fisheries. Tunde, I'll let you go first on an answer of this question. This doesn't directly relate to your presentation, so if you don't want to answer or just want to answer partially, we can go around to the other panel members and see what people have to say.
Thank you for that question. If I remember clearly, what the question is that fishers tend to operate dynamically. They go to where the fish is. So how do we account for that? I think Dr. Sheila kind of mentioned that earlier on, that incorporating economic information may actually strengthen this modeling. And so I think that's probably something to think about. If we know where the fish biomass is and we know how much it costs to go there, we will have some information on whether fishermen want to go there, particularly if it costs more than they are going to earn from selling the fish. They probably may not want to, travel that far. And so I can see a situation where Ecospace would redistribute fishing effort in a different way, if that's the case, right? But if fishermen will get enough return for their investment, then it makes sense that they travel to those fishing grounds, even if it's far away. I don't know if that answers your question, because yeah, inland fisheries is sort of different in a sense, but I think same logic can be applied.
Thank you, Tunde. Yeah, I'll add a little bit to that. It is indeed hard if you want to model fishes that spend a large portion of their time outside of your model area. There's a couple of things you can do for the diets. For example, you can have there is a line to include a percentage of the diet that is from outside of the system. For the biomass of your fishes themselves, you can set the amount of biomass to a proportion of the total biomass of the population, for example. That would then indicate what proportion of the population actually spend their time in your model area. Oftentimes, I think that comes down to, you could calculate that yourself too outside your model and just reduce the amount of biomass inside your model area. So that would take care of biomass. I think the most challenging one may be migration in and out of your system at certain specific times during your model run. And I'll let others chime in, but we don't really have good directed movement of fishes in the models yet that are not related to any of the environmental conditions, but just that it's time for them to spend time inside your model versus outside your model. So I think that's definitely something a lot of people are working on. So there may be some solutions that people work on outside of the software. So I'm going to mute for a second and see if any of the other moderators have examples of how they dealt with anything like that.
If I may chime in just a little bit, now I understand the question better. I did not realize she was talking about migration of species. I thought it was movement of fisher folks. And so what I will do would be maybe to, because in Ecospace, there is a tool that allows you to restrict where fishing occurs and when it occurs. So depending on when those biomass are within the system, we can set fisher folks to fish during those times and limit them fishing when the fish biomass is outside the system. So there's always a way around those kind of questions. We just need to sit down and think about it and figure out the best way to implement a solution to it, given the tools we have in Ecospace. Does that help?
Yeah, I think so, especially if you're interested in catch, and then of course we still have biomass that you may be interested in. So if anybody of the panel wants to add something, I'll mute one more time, and after that I'll move on to the next question.
Maybe I can say something. Sorry, I have really poor internet, and my yeah. Tunde, thank you very much for a great presentation. With regards to fish movements in and out of the system, you can have movements, and you can include migration, specific migration, moving them from month to month. That can be done with envelopes that moves them. You can move them out. You can't move them out of the system, but you can move them up in the corner and let them feed up there and not model the dynamics. What's important here is that if such a group is in there mainly because of the impact it has on other groups, then that works fine. The price you pay is you're not modeling dynamics of such a group. So if you put import in, they will always get that import, and you may have to do that, and you can do that, but you're losing the dynamics of it. So favorite example is you're working on a place like the Azores, and you're working on the fisheries of the Azores, and you have tuna coming in and leaving again. You can have that, and you can have the impact of the tuna. But if you really want to find out what happens to the dynamics of tuna, you have to expand the area, and you have to model that dynamics. You don't get it for free. So the model area really has to reflect what it is, what kind of questions you have. If they are the fisheries of Azores, and it's mainly based on the habitat inside, the fishes inside, it's fine just to have tuna coming and going. But if your questions are tuna, you have to model the whole area. I think that's
great. Thank you very much for that contribution, Billy. I have more questions coming in the meantime. The next one from Natalia Serpetti. Can Ecospace uncertainties be calculated running Ecospace scenarios from different Ecosim Monte Carlo runs? I would say that is actually what I'm working on with Joe. He has changed the capability of Ecospace such that some of these Monte Carlo runs can run in parallel. The issue that we've had trying this just by changing a little bit, you know, the Ecopath model, when you run Ecosim in Monte Carlo and then continue on an Ecospace, is the amount of time it takes. So we are actually working on that. So that pretty much the same functionality as the Monte Carlo runs in Ecosim are going to be a possibility in Ecospace. Does anybody want to add to that discussion from the moderators?
Yes. We actually developed this about 5 years ago for the work with Port of Metro Vancouver, and used it a number of times to run like 5,000 scenarios and another 5,000 model runs for a pretty complex spatial model. And Joe was involved in that, and we've been doing that again since then. So the main issue is that to take it from using it for an application like that into a version that can be distributed is quite a big step, and having it as routine in Ecospace that is distributed, well, there's the price we pay, and we have to pay from our programmers to do this, and it really is a big step from using it for an application to making it general available. It takes a lot more effort to make it generally available, but it's there, and there has been quite a bit of work going on spatial optimizations. As soon as you get into optimizations and looking at spatial uncertainty too, we have to use these approaches. And Kim, you could actually talk a bit about the work that we did last year on this, the report that's coming on this.
Sorry, Billy, was that a question for me? If I can talk about work that we're doing with this?
With the spatial optimizations and spatial uncertainty, that this relates very much to question of spatial uncertainty, that there was a working group on that.
Yeah, absolutely. So we're still working on that, and that is basically running the Monte Carlo function of Ecosim in space, but then in a way that can be done fast on having different runs on different threads. So I bought a bigger computer, and I think this will be soon be something we'll have outputs for. So right now we're using a model in the northern Gulf of Mexico for runs like that.
Yes, and I was also thinking we had last year a working group meeting in Barcelona. Or was it the year before maybe? And the report is coming. I think it's getting pretty close. That describes how to incorporate uncertainty in Ecospace.
Yeah, that's correct. That's great, Billy. So we are getting closer to the top of the hour. I am going to read, for those that cannot see the Q&A, another response of Sheila on the previous discussion about the model area, that it's indeed a question of setting the area, and that is probably indeed the best advice. If you can, just make your model area bigger and don't deal with migration. Sheila adds, for inland fisheries, you might have a similar issue with birds coming into your system at some stage of the year. And if they have a huge impact on your system, you might have to use the methods Billy used. Let's see, we do have some more questions. One more from Anonymous. Thank you all for the nice presentation and discussion parts. I have a question regarding future seminars. Is there a seminar in the future? How to learn Ecopath with Ecosim and Ecospace, so the very first steps. This seminar is very much designed to kind of broadcast like new uses of Ecopath with Ecosim, so that's why most of the talks have dealt with Ecospace. There are definitely workshops about learning Ecopath with Ecosim and Ecospace, which I think is a much better way to learn it than in a seminar. I don't know of the next upcoming date and where, so I'm going to open the floor again to the panel if anybody knows of a upcoming introductory workshop. The last ones we did were in December 2019, So they're offered now and then. I'll open the floor and see if anybody knows of any upcoming workshops. You're muted, Lee.
Thank you. I just wanted to come online to say that I've had a few requests from people that are watching the seminar series with exactly that request. And it'd be really nice if we could find out sort of how many people there are out there that would like to get some training. And now that we're doing so much education online with virtual systems, I'm sure it's something the consortium can work together on, trying to make, pull together, you know, an online course for Ecopath, Ecosim, maybe even Ecospace, and I'd be happy to help coordinate that. So if there are people on here that would like to email me directly, I'll put my email address in the chat box, and I'll just gather that together, and then I'll take it to the consortium, and we'll see what we can do, because I've had that come up a few times. So I'll put my email in there, and I'll put you back on, Kim, to finish off.
Great, thank you, Lee. So yeah, so that may be a great way to get the introduction into this modeling. So yeah, let Lee know if you're interested, and who knows what may come out of that. I think I have time for one more question. Or Lee, did you want to say something? Okay, I'm going to ask the last question. How would you model seasonal changes in diet? So I'll open the floor to who has worked with that.
It's a bit like you can't be a little bit pregnant. Either you're pregnant or you're not pregnant. Either you do seasonality or you don't do. Once you start going into seasonality, you have to think about how, take for instance, how productivity changes in the course of the year. You may have to think about a number of other questions, but for diet composition specifically, it would have to be a question of abundances changes. So you can't go out and direct it. You can't go out and enter an new diet composition for each month. It doesn't make much sense to do that. But you could have it that if you really go in and you do it seasonally, that the more abundant things that are preferred will be eaten more. So it can be addressed that way. But you really have to think about seasonality if you want to do it.
Thank you, Billy. Yeah, if I can add to that, if you are not necessarily interested in dynamic modeling, you could make a model in Ecopath for each season and figure out how the trophic interactions are different between the different seasons. But for for dynamic modeling, there's no good way to force it, although it may be an emergent property from what's available, as Billy was describing. All right, I think we have 2 more minutes. I see in the comments, for one thing, and I'd like to add my voice to that too, to congratulate Billy Christensen, who received the AFS Award of Excellence. So very well deserved, Billy. I think everybody here very much thinks that's a great prize, very well deserved.
Thank you.
Thank you.
And thank you for adding your voice to these seminars. It's very useful to everybody to really have some expertise on the line. I see another comment of somebody that would love training. So you see in the question and answer section the email address of Lee. Copy that. It will disappear as soon as we end this seminar, so that you can indicate if you want training. With that, we're on the top of the hour. I want to thank Dr. Tunde Adebola for a very great presentation today. Keep an eye out on the Facebook page, on Twitter, on the website for announcements of the next seminar, which will be in 2 months. And with that, I thank you all for attending.